Good morning. Good afternoon, good evening. Jia Shanghai, Xiao Hai, Wan Shanghai. Sorry I can't be with you in person in Hangzhou. De Buchi Wubang Xinga Shanghai Yuming He. And thank you both to Atia and Daniel for the previous presentations. Very interesting and very innovative to hear from the different corners of the world. So my name is Eric Deben, and I work for the Office for National Statistics in the United Kingdom. And I'm going to provide over the next 20 minutes an overview on the machine learning and the data science revolution, the value of machine learning for official statistics, international experience from the UNECE Machine Learning Group. I talked to a few use cases. I also like to give you some lesson learned and also what's the next steps in machine learning for official statistics. So machine learning is evolving very rapidly. As you can see, there ML and AI are already part of our everyday lives, as we heard many times over the last few days. They run many aspects of the digital world, from the apps on your phone to social media and streaming services. Machine learning gives computers the ability to learn from data without being directly programmed by human programmers. It's one of the new methods which data scientists are using to solve complex business problems with large and varied data sets. This is exciting times for machine learning. It makes rapid advances, as we heard early on this morning from Attilia. The rapid changes to increasing computing power, the speed we can see, the advanced methods, and the unpredictable growth of digital data. Machine learning depends on data. Computers are fed data and instructed to look to patterns. So the more data they have available, the more scope there is for machines to identify these patterns or learn from the information that they are fed. So as more and more services become digitalized and knowledge is increasingly being put to the web, machine learning has the ability to produce even more accurate data. So what's the ML value for official statistics? The data science revolution has the potential to improve the production of official statistics and the indicators. Statistical organizations, such as ONS, where I work for, are dedicating significant resources to explore ML values to their own systems. New technologies, such as machine learning, can enable statistical office to harness big data. For statistical agencies, we are particularly talking about non-traditional data sources, such, for example, as web scrape data, mobile phone data, and scanner data. Indeed, it's not possible to handle big data without ML. It's like big data is the oil, but ML is the refinery that produces useful products from this raw product. ML can also help to improve the efficiency of manual tasks and automate certain routine tasks. So most importantly, ML promises to help statistical office meet demands for outputs which are more relevant, more timely, and more usable to help governments set priorities, make better informed decisions, and implement better policies. So here are some of the areas where machine learning can be applied in the official statistical production cycle. This is the GSPPM, the General Global Business Process Model. We found it can help automate a number of manual repetitive tasks. It has proven benefits for a number of processing tasks, such as classification and coding, reviewing and validation, and editing and imputation. And let's look in more detail now in one of these areas. Coding and classification are essential to ensure data gathered from people or businesses are comparable nationally and internationally, but these processes are resource intensive, as we all know, often involving human experts reading responses and inciting codes them. However, with ML, this process can largely be automated. Human experts first work on a small subset of the entire dataset, and the ML is then used to classify the rest by learning from the patterns of experts' work. Such automated coding leads to faster release of figures, making them more valuable to end users. This not only has potential cost savings, but it also frees up staff resources for higher value work. So on this slide, you see lots of international logos. So as statistical organizations gain expertise in machine learning, many found that the collaboration has been key to accelerating this development. So the UK ONS Data Science Campus, where I work, partnered with the UNECE, United Nations Economic Commission for Europe, based in Geneva, is leading its machine learning group we led it from 2019 to 2022. It was a platform for the official statistical community to carry out research, collaborations, share use cases, and explore organizational integration issues and build capacity. 4 years of investment by ONS with the UNEC in building this ML community. Like 2018 was really like the setup year, and we started with about 10 to 12 members. And the last 3 years, from 2019 to 2022, we really looked at the implementation part. I mean, we gathered well over 400 members now from 30 different organizations, really across the whole world. We really traveled together on a learning journey. Sharing experiences of ML helped accelerate the research and development and gives us a realistic, informed view of what's required to harness the great potential of machine learning for official statistics. The knowledge we've gained of ML in NSO Internet can help all offices transform and modernize their operations. So what we did, so we did knowledge exchange, we research collaboration and capability building. I'll just build the whole slide. We did pilot studies, we webinars, we shared use cases, we did coffee and coding sessions, we wrote newsletters and published a lot of information on the website. We had in-person sprints. The power of meeting in person is really, really great. I mean, we had workshops in the UK, in Serbia, in UAE, in Brazil, and in Asia over the last couple of years. We focused in the first phase on understanding the value add of machine learning and the quality issues, like the coding classification and imagery were very much the most popular topics. The second phase was more the emphasis on the importance of ML for handling big data and a deeper dive into how to integrate with statistical production processes. So the phase 3 was very much like a deep dive into big data. We looked at research collaboration on web scraping, AES data. We also did some further investigation in quality, looking at training data and model retraining issues. I mean, across the 3 years, what were the outputs? We ran over 40 projects and working groups. We produced many technical reports. We shared code and methods, ethics and quality frameworks, and we wrote some very active papers as well on organizational issues for the integration ML into production systems and how to help with that. And we archived all of our recordings, our use cases, and also the best practice discussions. Here you see some feedback what the different NSOs found by working collaborative across the group for the last 4 years. And this was presented at the UNEC high-level modernization executive board meeting in November last year. One of my team members was there, and we had so much feedback, and we just put a few comments there. A summary of why we invested and what we achieved. I mean, a place to explore and test ideas. Sharing of tried and test approaches helps speed the process, target resources, enable organizations new to ML to accelerate the development, address common production challenges, raise profile of ML among strategic decision makers, and building staff skills. So a lot of really positive feedback into this. Now I will look in a few examples that kind of proof of concept. There's about 4 or 5 slides for this, so I'll just take maybe 2 examples, and the rest, of course, you can see when we share the slides. So this one is from Stats Poland, machine learning in the application area. What is it and how will it be useful? So using web scraping to produce more frequent statistics on the Polish property market. The first stage is all about experimenting with auto coding for different variables, kitchen type and security facilities. So how did this project come about? Like organizations encouraging staff to really to search for new methods and new sources to get more timely, more relevant statistics. Knowledge and experience was gained in the machine learning group. There was like a whole expertise teams under the guidance of Dominic with the CPI colleagues. They established the web scrape data on real estate, and it would be useful for comparison on the rental market. But also 2 favorable conditions to help launch is like the experience of the ML, where Polish regional stat office worked on automatic classification, and also the establishment of a central office on experimental techniques. So we had kind of 3-4 different units working together on this. So what was needed? I had to set up an IT infrastructure, some remote servers, some dedicated disk space, outside organization, internal web, version control scripts, API connections. They acquire data. And of course, that's the key part of this. They had to do some data cleaning and to prepare validation rules. And then they had to apply some auto coding. But what's very important is the results. So more than 72% of the automated classified data with a probability of 95. That's high. It only took 1 week for 4 people to manually classify these 2 variables from like 6,088 out of the 8,881 non-duplicated adverts. So it really shows that with ML you can start seeing less errors, more time efficient, and it's very replicable. I'll just take another one here. So this one is from the IMF, the International Monetary Fund. So the aim for the IMF was really the ultimate goal was to build a tool that can be used by the IMF staff working on attributing codes to non-code indicators from country upload files and help speed up and automate this work from a user perspective. So having a solution that's easy to use requires minimal training. It's also close as possible to the current process is a key factor in the success of such a tool. And to facilitate, the team built an Shiny app, allowing the user to interact with the different functionalities of tools and then generate predictions following the process shown below. Like we had first of all, a maintenance plan, consistently updating the training data with new data, predictably retrain the model data, then looking in improving the overall quality of the predictions, but also then improve the CTS classifications in the Shine API by allowing the user to review, accept, or reject. And also then override the assigned code by a model directly in the app. So the progress made is fully automated proof of concept. We created a package for ML. That's all available now on GitHub. We also have published an internal Shiny app for users to run a model and to predict codes. So the expected impact for improving business processes and outputs, and the current version hasn't been implemented, but we expect a considerable gain in time. We improve the quality of the assigned codes and free resources, allow staff to work on this with more analytical tasks quicker. So why did they find the work with the ML group beneficial? They played an important role because the knowledge and expertise shared from technical and logistical aspects provided a platform to present the work and feedback from the peers across the different organizations, and understand also what are the main machine learning challenges faced by other international, other international organizations that also want to really build the data science community. So I'll very quickly on the next two. So this one is from Mexico around auto coding, and the aim really was here to increase the quantity and quality of the encoded rigid automatically, which they use support vector machines. And so in the organization they have a project now codifying variables of occupation and sector of economic activity in different surveys and population and housing census, achieving to increase the quality and the quantity of records encoded automatically for household income and expenditure survey. So it would mean an improvement in the rest of the projects. So the last one is around the US workplace for injury. So the aim really for this is to improve the quality and the efficiency of coding circumstances of work-related injury and illness collected by the Bureau of Labor Statistics. I mean, traditionally, 300,000 reports are collected each to survey of occupational injuries and illnesses. So they have to read through every category. So ML helped to build that change. They looked at some primary data input, and then they fold the ML process. And this now is assigned to, so the occupation is assigned to according to the SIC, the SOC, the standard occupation standard. So the data preparation didn't seem valuable enough. So the 6 classifications was assigned to each case based on the SOC. And what I did to the different models that they tried logistic regression, they tried support vector machine, variants of naive Bayes, random forest, and multi-layer perceptions, and many variations of convolutional and recurrent neural networks. The result? Results show two important findings. First, machine learning techniques like support vector machines and logistic regression can produce more accurate coders than naive Bayes. Second, these more effective machine learning approaches can also achieve classification accuracy similar to or better than those achieved by human coders. And that's an interesting one. So it can already receive higher results. So I talk a few minutes about how machine learning has potential applications for the NSO. So what did we learn? Number one, machine has many potential applications in the statistical organizations. The main ones are for classifying survey responses, handling big data, register data, and pilot study shows how ML can improve relevance, timeliness, and efficiency of official statistics. The potential of ML for official statistics is genuine and of huge importance. I mean, as seen on the web scraping team, ML is essential for tool for making used or web scrape data, which the statistical office are increasingly looking at new data sources. It's simply not feasible to do this manually, processing for type of data. Text classification and imagery classification were the most popular use cases in the statistical organization. And we also learned about some of the new applications in 2022, like predicting with survey response to select for follow-up questions. That was from the ABS. We're creating more evidence-based survey frameworks, and we also triaging multilingual customer inquiries. We also saw like use cases outside this usual application area, like the using of ML to select survey response to follow up. We looked at efficiency sorted to customer injuries. We assist samples by selecting companies that like to engage in particular industries, and this will continue. The second one is the machine learning has huge potential, but quality concerns needs to be addressed first. There are also legitimate reasons and concerns about the introduction of ML due to the rigorous quality standards, which are fundamental to the operation of official statistics. The drive to move forward with innovation needs to be balanced against a need to understand the implications for quality. For statistics, quality, of course, doesn't just mean accuracy, but also other dimensions such as timeliness and cost effectiveness. The third one, you see the picture of the iceberg there. The integration of ML into existing statistical policy requires resource, strategy, and time. Integration in machine learning requires more than just ML skills. As with all the methodology and methods you need after the initial experimentation, it needs a supporting environment and infrastructure to scale beyond specific small group of experts. There are many resources available for learning how to write ML codes or run neural networks for text classification, but we don't yet have clear direction on how to best put an ML model into production with the complex organizational structure of a statistical office. This is the part of really time consuming and requires most heavy lifting. So next steps in the ML collaboration. In June, we have a workshop planned in Geneva. This is open to anybody. These representatives of the member states, the United Nations, and interested organizations are really welcome to come there. We asked participants to register by the 20th of May, so that's in a few weeks' time. Most of the work from the past 4 years is available online, so you can view this on the UNEC ML Group Technical website. We have their reports, we have case studies, we have meetings recorders, and we also got many slides on the website available, and you see the link there as well. So please log into that after this presentation. If you like more info needed, so we also talk about the UN Global Platform. So the purpose is working together to educate and to collaborate and develop new technologies to work with our new big data sources and methodologies. A platform that enables NSOs to access and process big data, particularly AIS and Earthization. Without having an own in-house IT infrastructure, you can make use of this. We also contains method, code, guidance, and use cases. We have the UN Learning Management System, the Big Data Competency Framework. We have the Majority Matrix, the curriculum, and the online training. And also we have lots of learning activities there, collaborative NSO projects, webinars, training courses, hackathon, and workshops. And of course, as you're all in Hangzhou, of course, we got the big regional hub that looks after the whole Southeast Asia area. So please speak to members there, and to members from the UN DESA group for the UN Data Science and Big Data group. So, in summary, data science innovations is transforming statistical work. That's a given. It's happening. ML is vital for handling big data and can help automate manual tasks, but it raises quality and ethical concerns, which we need to improve on. Statistical organizations have developed many use cases that demonstrate the value of ML, and also the focus is now on the challenge of how to integrate machine learning in establishing production systems. This is the end of my slides. Thank you very much.